Hello friends, let's solve this interesting Olympiad problem. So let's solve one interesting maths Olympiad problem. In this problem we're having that if ABC are natural numbers, then find the number of ordered pairs A, comma B, comma C, such that here 2 to the power of A plus 4 to the power of B plus 8 to the power of C is equal to 328. So given for us here it is 2 to the power of A plus 4 to the power of B plus 8 to the power of C is equal to 328. So how do we solve this problem? We'll see. This is given, and it's also given that A, B and C are natural numbers. This is also given to us. So now here how do we solve this? We'll see. It's very interesting. See this. Here you're having 2 to the power of A plus 2 to the power of 2 whole to the power of B plus 2 to the power of 3 whole to the power of C is equal to 328. So this is equal to, here we'll get it as 2 to the power of A plus 2 to the power of 2B plus 2 to the power of 3C is equal to, you can write this as 8 into 41. 328 can be written as 8 into 41. Now this can be written as, here we are going to write this as 2 to the power of P plus 2 to the power of Q plus 2 to the power of R is equal to 8 into 41, such that over here you are getting that P comma Q comma R is equal to, we are writing in the place of A, 2B and 3C, such that P is less than or equal to Q is less than or equal to R. It doesn't mean that P is equal to A, Q is equal to 2B or R is equal to 3C. In the place of this we are writing the ordered pairs in that manner. It can be A, 2B, 3C. It can take any value of that P, Q, R. So at the end of the problem you'll understand why we have written like that. So now here this is equal to, you can take out here 2 to the power of T plus 2 to the power of Q plus 2 to the power of R is, which is equal to 2 cubed into 41. 8 can be written as 2 cubed. So now this can be written as, here I can take out 2 to the power of P common. If I take out 2 to the power of P, I'll get here 1 plus 2 to the power of Q minus of P plus 2 to the power of R minus of P, which is equal to 2 to the power of 3 into 41. Now this and this can be equated to this, so you can take it, if you want you can write it in a different color. This can be equated to this part over here because the base is 2. So you can write this as 2 to the power of P is equal to 2 to the power of 3, which implies that P is equal to 3 we got now. Now next again you are having what is left out, we are having again here 1 plus 2 to the power of Q minus P plus 2 to the power of R minus P is equal to 41 we are having. So now this can be written as 2 to the power of Q minus P plus 2 to the power of R minus P is equal to 41 minus 1, which is equal to 40. So this can be written as 2 to the power of Q minus P plus 2 to the power of R minus P is equal to 8 into 5. 8 times 5. So now here I can take out 2 to the power of Q minus P common. If I take out 2 to the power of Q minus, so we get it equal to 1 plus 2 to the power of R minus Q, which is equal to 8 times 5. 5 or 2 to the power of 3 times 5. So this implies that 2 to the power of Q minus P is equal to 2 to the power of 3, which implies that, here you can write it in a different color, we'll write it in blue. So you're getting the powers, the bases are equal, so you're getting Q minus P is equal to 3, which implies that, now here you can name this as equation 1, we'll name it with green only here. So this is 1. Now from 1 you can substitute this, from 1 P is equal to 3, therefore Q minus 3 is equal to 3, which implies that Q is equal to 3 plus 3, which is equal to 6. So we got now P is equal to 3, Q is also equal to 6. Q is equal to 6. P is equal to 3, Q is equal to 6. Now next what is more left over here? we are having here again from this equation here you can see that it is left over 1 plus 2 to the power of r minus q is equal to 5. So now you can write this as 2 to the power of r minus q is equal to 5 minus 1, which is equal to written as 2 to the power of r minus q is equal to 2 to the power of 2. Now since again the bases are equal, you can write here r minus q is equal to 2. Now you know that q is equal to 6. So r minus 6 is equal to 2. This you can take it from here. This you take it as equation 2. So therefore you are getting this as equal to from equation 2. So therefore which implies that r is equal to 2 plus 6, which is equal to 8. So we got that PQR is equal to A, 2, 2B and 3C. That means here you are getting this is equal to nothing but we got it as 3, 6 and 8. That is PQR in this order. We got these numbers. Now write what is the question which we are having. The actual question 2 to the power of A plus 4 to the power of B plus 8 to the power of C is 328, isn't it? So this can be written as 2 to the power of A plus 2 to the power of 2B plus 2 to the power of 3C is equal to 328 we are having. This is also written as 2 to the power of P plus 2 to the power of Q plus 2 to the power of R is equal to 328, or we got this P value as 2 to the power of 3 plus 2 to the power of 6 plus 2 to the power of 8 is equal to 328. So what are the combinations of this PQR we are going to get? We'll just see. So PQR, what kind of equal to nothing but A is equal to, next this is equal to 2B and this is equal to 3C. So now what are the combinations of these? We can take 3, 6 and 8. These are the numbers of P, Q and R. So now here definitely R should be a multiple of 3. So if we take the 3, here it should be a multiple of 2. So it can be either 6 and 8 over here. If we again taking 3 over here, it can be 8 over here as Q and P can be 6, because here Q is a multiple of 2. Now if we take here 6, because R is a multiple of 3, so 6 is also a multiple of 3. So what do we get? Here Q should be a multiple of 2 and this should be 3. So we cannot find more combinations. So what are the different combinations of ABC we get is ABC is equal to, you can write this here, PQR, you can have 3 types of combinations. Here first, here it can take values as 8, because here 2B is equal to, so here you can write here, since it is A is equal to 8, 2B is equal to 6 and 3C is equal to 3. This is the first combination. Just write here, it is equal to nothing but 8 comma, here this is 6. So this is 3 over here and this is 8. So 8 comma 6 by 2 is 3. 3 by 3 is 1. Next combination of ABC is equal to combinations of ABC. So ABC are natural numbers, we know that. So what are the different types of values you can take? Here again A is equal to 6, 2B is equal to 8, 3C is equal to 3. Then here again A is equal to 3, 2B is equal to 8, 3C is equal to 6. So what are the different combinations we can take over here? A is 8, 2B is 6, means B is equal to 6 by 2, that is 3. C is 1 over here. Next combination of ABC is equal to, first you can write this as 6. Then you can write 8 by 2, that is 4. Then 3 by 3 is 1. Then again the last combination which we can have is A is 3, B is equal to 4, C is equal to 2 you are getting. So these are the 3 different combinations of numbers. See here you can see, then find the number of ordered pairs. So the ordered pairs, we are having 3 ordered pairs which we have got. These are the ordered pairs of A, B and C. please subscribe to my channel for more videos of this type. And you also have from my channel videos of 10th class CBSE solutions. All the chapters are done. You can watch my channel, and my channel is given in the description over there, so you can please go into what all videos are being done. And even 11th class up till chapter 5 is done. All the chapters are done with the solutions. Please subscribe to my channel.